Time series analysis is a method to predict future values by breaking down variable factors into factors such as long-term trend, cyclical variation, and irregular variation using statistical methods based on data arranged in chronological order. It is one of the techniques of regression analysis. General regression analysis is used to determine the relationship between objective and explanatory variables, whereas time series analysis is used to derive a formula for the relationship between current variables, which are objective variables, and past values. The key point of time series analysis is whether data can be broken down according to past data changes from the following three viewpoints. For example, assume that daily data fluctuate up and down, but the annual average values increase gradually every year. In this case, the data are considered to be increasing as a long-term variable factor. By observing waveforms of past data, the data are broken down into three factors. A. Long-term variation factor. Long-term trend. B. Seasonal variation factor. Annual cycle, monthly and weekly cycle, and daily trend. C. Irregular variation factor. Erroneous variations, etc. There are two ways to break down factors. The additive model, which is given by A plus B plus C, and the multiplicative model, which is given by A times B times C. The multiplicative model is applied to the case where the final data can be correctly explained by interpreting that it is the product of the multiplication of two or more factors. A model that properly represents the change in past data should be chosen. The basic concept of time series models is to use past values as explanatory variables to derive a formula that gives the current value. In statistical terms, it is the regression of current values from past data. There are 5 typical models. They vary in complexity. One model directly describes the relationship between past data and current values in a formula. Another breaks down the relationship into long-term and seasonal variables separately. Below, the 5 models are described in order. The difference between the models lies in the form of the formulas, which describe current value using past data. By defining the form of a formula, the coefficients can be determined so as to minimize the error between the actual data and the values obtained from the formula. This is called the least squares method. 1. AR model, which stands for autoregressive model. The autoregressive model assumes that the current values are affected by past values only. An example is the single regression model that predicts the sales of a particular day, based on the sales of the previous day. Another example is the multiple regression model that predicts the sales of a particular day, based on the sales of the previous day and the day before the previous day. The key points are the number of days to be regressed, which is used as an explanatory variable, and the assumed time lag. 2. MA model, or moving average model. The concept of the MA is the same as that of the AR model, in that current values are affected by past values. However, in the MA, current values are assumed and formulated to be affected by the average of past values and by past errors, the difference between actual and predicted values. As an illustration, it is similar to predicting today's sales, based on the average value of the sales, until the previous day and the errors in the past values. Note that, the meaning of the term moving average in this model is different from the general meaning of the mathematical term. 3. Arima model, or autoregressive moving average model. This model is a combination of AR and MA models. This model assumes that the current value is affected by past values and errors. 4. Arima model, or autoregressive integrated moving average model. This model is the Arima model with trend factors excluded. It assumes that the average value of the time series data changes over time, and incorporates those changes into the model. This model is the Arima model excluding trend factors in each season. 5. Arima model, or seasonal autoregressive integrated moving average model. This model is the Arima model incorporating cyclical variation, that is, seasonal variation factors. The Arima model is used for both time series variation and cyclical variation to regress the current value from the past data. It is practical to set the value of the cyclical variation in advance, for example, 12 months, otherwise, there would be an enormous number of patterns of formulas that can be applied.